Example 4, express the difference as a product. So this will be one of the identities from the previous page. We're going to want to look for cosine of an angle minus cosine of an angle. So that's this very bottom one here. So it looks like we're going to want minus 2 sine, let's see, we'll get there. Minus 2 sine, and then it was the sum of the two angles divided by 2. So that's pi over 12 plus 5 pi over 12. And then this is all over 2. And then we have not plus, but times something else. Let's see what that something else was. And then it was sine of the difference of the two angles. And notice it should be the first angle minus the second, alpha minus beta. So sine of alpha minus beta. So we have sine, we have our first angle, which is pi over 12, minus the second one, and then all over 2. So we get minus 2 sine, and I'm just going to do a little bit of side work here. If we were going to do pi over 12 plus 5 pi over 12, that would give us 6 pi over 12. And then if we were to take that and divide it by 2, so 6 pi over 12 all over 2, okay, this would be 6 pi over 24, which is equal to pi over 4. So this is going to be, once I get this to red, it'll be pi over 4. And let's try the next one. The sine of pi over 12 minus 5 pi over 12 over 2. So we'll do our work here on the side again. So right, this time it's pi over 12 minus 5 pi over 12. So that's minus 4 pi over 12, which is equal to minus pi over 3. And if you were to take that and divide it all by 2, it's going to be minus pi over 6. So we have plus sine, times sine of negative pi over 6. And so this gives us minus 2. Sine of pi over 4 is the square root of 2 over 2. And sine of negative pi over 6 is going to be minus 1/2. So this just ends up giving us the square root of 2 over 2. I do want to say one thing here. This question did only say to express the difference as a product. We are technically done with that when we got to this point. The only reason I continued to go further is we were able to find what the values of sine of pi over 4 and sine of minus pi over 6 are just with quickly using our unit circle. Let's go ahead and verify just one identity here. So we have cosine of 4x minus cosine of 2x. I don't know why these, every now and then I have random letters missing here. But cosine of 4x minus cosine of 2x over sine of 2x minus sine of 4x is equal to tangent of 3x. I like the idea of starting with the left-hand side here because I can see just by looking at it, we're going to be able to use our sum to product formulas, or in our case, we have a difference here, right? But we're going to be able to turn these into a product. Maybe we'll be able to get some stuff to cancel and maybe hopefully end up with tangent of 3x here. All right, we'll go up and peek at these one at a time here. So we have cosine of 4x minus cosine of 2x, and I think we just used that one, right? It's yeah, it's this very bottom one here, cosine alpha minus cosine beta. So we'll have minus 2 sine of the sum of the angles divided by 2, sine of the difference of the angle divided by 2. So we have minus 2 sine the sum of the two angles all over 2 times sine of the difference of the two angles all over 2. And then we have sine of 2x minus sine of 4x, which we should be able to find a formula for that as well up here. And it looks like it is this second one here. So we'll have positive 2 this time, sine of the difference of the 2 divided by 2 times cosine of the sum of the 2 divided by 2. We might have to come back up and look at that. So 2 times the sum of, I believe it was the difference. We'll go up and double check in a second. So sine of the difference, let's see. Yes, that was right. And then times cosine of the sum of the angles divided by 2. Cosine of the sum of the two angles divided by 2. So if we start to simplify what's inside of all these trig functions, should be something fairly nice. So we have sine of what looks like 6x divided by 2, so that would be 3x. And then we have sine of just x all over 2 sine of negative x cosine of 3x. Before we move on to the next step is what I want you to note here is that sine is an odd function, which means that negative you see there, I could bring that out front if I wanted to. So I could rewrite this as minus 2 sine, and I'm actually going to even switch the order of my signs here, right? The order of multiplication doesn't matter. So sine of x times sine of 3x, and then all over. And we have, again, I'm going to bring this minus 2 out front because sine is an odd function. So I'm going to have minus 2 sine of x, and then times cosine of 3x. And you can see that we have two sets of factors in the numerator and denominator that are identical. So when we divide these things, we'll just get 1. And then lastly here, you're left with sine of 3x over cosine of 3x, which is tangent of 3x.